for this second part of the solution to 2010. Well, let's look at question 4 and 5, and I'm going to end with first questions. It's hypothesis testing basically of Z tests. So I'm going to write the null hypothesis and alternative hypothesis, and also the state the null distribution. So clearly this is a mean equal to 600, and now I thought alternative hypothesis would be when it is not equal to 600. And how do we know that? You can check the value of 600 is the average mass of 600 here. This is standard deviation, so if you look carefully you will find this. And then when they ask for two-tailed Z test, so that is it. So this actually gives you the idea what the null distribution should be. So this is a distributed anomaly, mean 0, and standard deviation of 1. Then for us to determine whether the null hypothesis should be rejected or not, we need to calculate first the Z value, the test statistics, and then the p-value, and then compare with 0.05. And if you check carefully, this the sample size was this, and then the mean of the sample 595, and the population's mean 600, and the given standard deviations was 130. So you will find that the test statistics is roughly negative 0.471. We use n mu, and then the sigma, and so as follow. And the calculation of the p-value will be like this. So this is the null distribution is like this, 0. So here is a negative 0.471. We need to take the other side to calculate the the critical region. So 4.7471 or so. So this is a critical region here. These two sides. And so for the calculation of p-value, we just use technology, the normal CDF. This enter very negative number, negative 100 would be sufficient. This to calculate this area, this one, and then mean 0, and then a standard deviation of 1. But however, because we're going to calculate total of both regions, so we're talking about time multiplying the answer by 2, and you get approximately 0.638, and this value is greater than 0.05, the significant level that we set. And so this is a case. We then conclude that there is insufficient evidence to reject the null hypothesis. So there is really, well, insufficient evidence to support the claim that mean mass of mangoes from Darwin is, well, really different from Lockyer Valley. Now moving on. So before we'll try to solve the fifth question, so we'll take a look at well, this really normal distributions, mean, and also standard deviation provided, and you actually asked to find also this k value later, and also to calculate this, also to basically to find unknowns. Let's go back up here. And so because the mean is 34.5 seconds, so the probability of having less than 34.5 seconds would be just cutting the probability into half total probability, so you get 50%. And then for this one, this here really means well, we translate it into probability. It means that the probability of having athlete running more than k seconds is equal to 0.055%. And so really this is 0.05%, and but we want to, then we won't be able to find this, so we switch to this where x is less than k, and I aims to find the value of k. So using technology, so we count the inverse normal 95%, and the mean and standard deviations 43.2. That means about 5% of the athletes would be running 43.2% or even longer. So for the last part, this is we're given this one, and well, I'll try to illustrate this using the curve. So now when I have this illustration, you can see that the area lying between A and B is white area region is 0.87. That means that the total of these two region, this is the shaded one, is a total of 1 minus 0.87, and that will be 13 or 0.13. But because we be actually symmetrical, we dividing these two into two equal region. So we divide this into 2. So you should divide this, and you end up getting 0.065. And so the area of here from A and to the left is really 0.065, and this area also 0.065. But let's focus on this. So first we try to settle this part here, and the x really is actually distributed by central limit theorem says that by mu, but the standard deviation is, or the sampling error, is this one. Okay, so you get approximately 31.96, and employing a similar idea, but this time we're going to use this area, this whole area right here, all the way until before B. So if you think about this, the area of this 0.6065, and here is 0.87. So we're going to calculate this. So this will be this total area, so that is 0.935, and calculate the inverse normal, you get B equal to 37.04. So finally, just come to the first questions. What I'm going to do is just going to write all answers from part A until part D, and just briefly explain later. So the random variable C is distributed normally with mean 72 and standard deviation 24, given right here. Recall that 72 because 1 hour 12 minutes of that's mean. So with the probability of between 60 and 90, this one, and the probability of x greater than 120 will be this one by technology. Now, since we're talking about the mean spread of the mean, behavior of the mean, according to central limit theorem, this will be the right histogram because it have less variability, and it is approximately normal. And something like this, I can show you something like this. So following that diagram, histogram B, and the reason is because it approximates normal with you can say less variability, or you say it's narrower graph, or even maybe the less dispersion and so on. So here they ask us to calculate the standard deviations and mean for when it's 100 and sample of 500. So we gotten them, and clearly the both values are shown. So then here we have the tablets packed in the bottles of 120 tablets, and then we want to test or test a claim that is effective relief against that allergy for more than 90 minutes. And so this is again using central limit theorem. We calculate this standard deviations, or the sampling error is this, and the probability that this drugs going to work more than 90 minutes is then by using technology you get this. So what does this answer here imply? This value is so small, so that implies, and that would be the probability that the tablet works more than 90 minutes against that said allergy is very low, or you can say that's something like not likely, for example. You can say that because the probability is so low here.